Talking about chapter 16. This is part 1, and it's all about geologic time. So this is a very nice picture showing the different layering of the different formations in the Grand Canyon. So when we're looking at geologic time, there's two ways we can date. We can date using relative dating techniques where we're determining the age of an event as compared to other events. So we're basically going to place the geologic events in their chronologic order. We're not going to be concerned with exactly when the events occurred. We're looking at which event occurred before another event. And then we also have numerical dating, and that's called absolute dating. In this type of dating, we're looking for a specific number. We want to look at the dates of the rock units or events, and we're going to express them in years before the present. In this type of dating, we use radioactive decay techniques. So this shows you a picture of the geologic time scale. This time scale was constructed using both relative dates and numeric dates. So our early concepts of geologic time started back with our early Christian scholars, and they used scripture to determine the age of the earth. They initially said the earth could be no more than 6,000 years old. Then 18th, 19th century came about, and based upon science, we determined that the earth actually cooled as a ball of lava about 75,000 years ago. Sediments were deposited about 2 billion years ago. And it was in the 18th and 19th century that we were starting to formulate some of our geologic principles that we use to help us unwrap the Earth's history. So one of the important people in geology is a man by the name of James Hutton. He is known as the father of geology. He did very detailed studies of rock formation and geologic processes. He came up with what's known as uniformitarianism. Uniformitarianism is the same process that is observed today has operated over a vast amount of time. So basically what you are looking at today also happened in the past. Now, Charles Lyell in the 1830s, he wrote a book called The Principles of Geology, and he championed uniformitarianism. He established uniformitarianism as a guiding principle in geology. Another way you can think of uniformitarianism is the phrase, the present is the key to the past. So we're looking at things that happened in the present to get some knowledge about what happened in the past. So let's look at our relative dating techniques. And Nicholas Steno, he came up with the fundamental principles of relative dating. In his first principle, known as the principle of superposition, he states in a vertical sequence of undeformed sedimentary rock, the relative ages are determined by the sequence. The oldest rock is going to be at the bottom. The youngest rock is going to be at the top. So down here would be our oldest rock. Up on the top would be our youngest rock. Another principle is the principle of original horizontality, which tells us that sediments are deposited in horizontal or nearly horizontal layers, like you can see in the Grand Canyon. So if there's ever a time that sediments are not in horizontal or nearly horizontal layers, we know some deformation must have occurred after their deposition. Another principle is the principle of lateral continuity. So our rock layers extend outward in all directions until they terminate. So if you look at the picture in A, you can see this sandstone layer, the yellow color. But when we look in picture B, notice that yellow bed, that sandstone, is not touching one another. Well, by employing the principle of lateral continuity, we can assume that that sandstone bed was deposited all at the same time, and then it was eroded away in certain locations. We also have the principle of cross-cutting relationships, and it tells us that an igneous intrusion or fault must be younger than the rock it intrudes or cuts across. Your igneous intrusions, or what we learned about, our dikes, our sills, our batholiths, our stocks, and so on. So if you notice that in the top left picture, the dotted line that's labeled fault is going to be younger than the existing rock. On the bottom right, you can see how we have layer 1, 2, 3, and 4, and then we have that red dike cutting diagonally across it. Well, this principle of cross-cutting relationships tell us that the dike is going to be the youngest unit. We have the principle of inclusion, which tells us inclusions or fragments in a rock unit are older than the rock unit itself. So when you look at layer B, notice you see pieces of A included in rock unit B. So that tells us those little pieces that are in B are actually older than unit B. This is another slide showing you some of the principle of inclusion. So in picture A, we know that the sandstone is older than the granite batholith. In picture B, we know that the sandstone is younger than the granite batholith because it contains pieces of the granite. Picture C, you see this outcrop from northern Wisconsin showing basalt inclusions in the granite. So we also have our relative dating methods, and another one is our principle of faunal succession or fossil succession. And that tells us that fossils, especially groups or assemblages of fossils, succeed one another through time in a regular and predictable order. So fossils at the bottom of the sequence are older than those higher up in the sequence. So we can put events in order by just looking at the fossils that are contained in those beds. So those are our 6 principles of relative dating. This ends part 1 of chapter 16.